Now let's officially get started. It's a true honor to welcome our first guest of the day, Gallagher from Dealers Cofido and Hanfro. And before anything else, on behalf of the entire team at Architecture Hunter and Morfolio, I want to offer a huge congratulations to Sean and the entire Dealers Cofido and Hanfro team. They have just received the Golden Lion at the Venice Biennale, which is the highest honor you can get there. It's such an incredible and well-deserved achievement. So, Sean, congratulations once again, and welcome. We are so happy to have you with us today.
Hey, appreciate you guys putting this together and can you guys see my screen?
Yes.
Yeah, great, perfect. I've never done this before. This is kind of sharing some personal stuff because it's really about tinkering, how we kind of do things behind the scenes or how I kind of obsess with things behind the scenes that eventually make their way into projects. So whether it's repurposing existing technologies for energy, carbon, and waste, or talking about emerging technologies, all this stuff has to be done at a smaller scale to really understand how it can influence things at a bigger scale. So bear with me. This is kind of just a talk that's rough and kind of spontaneous. Energy itself and tinkering with energy. This is Port Jervis. It's the last port up the Delaware River in New York, just on the south side of the Catskills. And like any kind of Rust Belt city, it's sort of lost its industry. The glassmaking industry was there, kind of moved on, and there's a lot of material, that needs to be repurposed or unused. The ports aren't moving any longer, but obviously they have a lot of that material still left. And so I personally thought maybe this would be an opportunity. It was pretty close for me to drive. Maybe this would be an opportunity for me to personally just try to go completely off grid in a way, using old industrial materials to build something that basically it's more or less 3 bedrooms, 2.5 bath, that I could tinker with to really kind of understand how this technology is growing. And this is not, like I said, this is behind the scenes. This is not particularly a DSR project. This is kind of me personally testing the technologies. This is, me, my family, couple friends, kind of, welding things together, reusing old angle irons found at the ports, to kind of build this place to see if we can make it happen, and really learn from it. What I found was that the solar panels I was using, I wanted to use bifacial solar panels. I really wanted to kind of test out that technology. And what I found was that it produces energies on both sides, which is really great. So I sort of lifted it off the containers. But what I found is that they're much heavier than regular solar panels because they have glass on both sides. And it was really hard to kind of move around and place on top of the structures. And the interesting thing was that in wiring all the panels and running all the wires underneath these solar panels, you can see it's a mess. It took me some time, and it's cleaner now. But what was kind of unbelievable was that the temperature difference between me lifting these panels up off the roof, 2 feet, I could slide under them and kind of work with the wiring. The temperature difference was like night and day. It was like 10 degrees different. As soon as I kind of walked out from underneath that space wiring and kind of stood up into the sun, it was it was unexpected. I knew it was going to be different, but I didn't know it was going to be that different. Eventually, I was able to kind of, get everything working. Took some time. Like I said, these are raw videos of me just trying to figure these things out. And so I loaded the software onto the inverters there, and they're a 14 kW array system with about a 30 kW backup system that I'm running there. And what I was kind of impressed about was that in the end, just with that 14 kW, I was able to support everything in this project. And the coolest thing actually was that after a while this thing was running, I was actually doing welding off of the sun's energy, which was just weird, but kind of cool at the same time. The other thing is that, you kind of have to control these things and know how to control these things so you can talk to your clients about this. And so I started actually taking a look at the beta software that the company EG4 was trying to kind of hack together for regular, hobbyists to kind of figure out how to use and kind of run their own systems. And what you're seeing here is my place running, and you're seeing not a lot of energy, right? You're seeing only about 345 watts. And that's because the array system itself was able to support, all the kind of plug loads, all the kind of refrigerators, all the things that we were kind of doing, and overnight, and sort of charge itself back up by 10 o'clock. And that's what you're kind of seeing right here is that by 10 o'clock, it's kind of fully charged. And then it obviously ramps itself down, and only uses the energy you need, for the plug loads or whatever you're doing. The biggest thing that I found was that the heating and cooling water, we take it for granted. It's happening at power plants, it's happening everywhere. There's a lot of energy going into heating, cooling, and water. This blip here is basically the hot water tank going back on to reheat the water back up to temperature after it was sitting for, you can see, like 6 or 7 hours. And so none of the other loads in the project are actually anywhere near that. And it's these blips that are kind of interesting. But going back to the canopies, and thinking about this interstitial space in the canopies, I started to think about the way that this could be used, and we started experimenting it on a kind of larger scale, in Moscow. So we took this concept to Moscow and kind of along a demoed site, along the river in Moscow. And what we wonder is if we can create, one thing, the big master planning effort was to create a wild urbanism. So taking regional landscapes, from around Moscow, bringing them into the urban center, in order to basically integrate them with a series. It's about a campus of 5 buildings. But we thought that perhaps we can kind of create a space where this could be passively run. This campus can be passively run. The outdoor spaces, the exterior spaces, off of the sun. So it was a park, but it was also a campus of buildings. And we kind of created this glass crust, which you see on the right, here, over top of one of the hills that we created there, that we had an amphitheater underneath. And we thought that in that interstitial space, not only could we kind of harness energy, but we could also kind of change the temperature so that seasonally people could stay outdoors longer. It gets really cold in Moscow really quickly. And so what you're seeing here down at Bob corner is kind of this glass crust, we called it, that sort of overlaid over top of a landscape and was kind of generating energy, but also allowing light through to kind of change the kind of temperature between that and the amphitheater. And so what happened was, and you can see kind of the thermal modeling for this, what happened was that, one, obviously it reduces all the loads of the building below it, but at the same time, it was creating open space that would normally not be used during the winter. And we thought that this way of kind of manipulating the sun and layering with a certain amount of distance away from Earth, we would be able to have a little bit of spring in winter. And so what you're looking at here is in winter, you can see Moscow in the distance, and there's snow. This is not enclosed. This is not a greenhouse. It's completely open. You saw the kind of airflow diagrams. But just in that ability to manipulate light for growth, but also for energy to keep the ground a little bit warm, we're taking the waste energy and putting it into the ground as well, to keep the kind of environment healthier, longer throughout the year. And so, talking about, keeping the environment healthier, moving on to another topic, where I'm sort of experimenting with is, just carbon, right? Attacking carbon is a kind of a big kind of part of how we have to start to build healthier. And back in Port Jervis, the growth that's around Port Jervis, around the kind of containers I'm playing with, is its second stage of growth. This whole area was sort of harvested at the end of the 18th century, for tanning oils and also for wood to build things, and specifically building ships too. And so there's old logging roads still in this area, and this is one of the logging roads. But in order to kind of get back there and kind of play with what I'm playing with, we did have to take down some trees. Fortunately, a mile and a half down the road, one of the neighbors had a portable mill, and I said, well, this is an opportunity for me to learn how to use wood, and in a kind of in a different way. So started to mill the wood, started to learn how to use a mill. itself, just kind of weekend warrioring this whole thing together. And what I found was interesting. When I started trying drying the wood naturally, you got to realize that the forest itself was completely deciduous, and so it had some evergreens and it had some deciduous, and it was kind of a mix. So I had a lot of different type of wood types. And one of the things that I found is when we started drying them, we cut them and milled them pretty straight. And I was really interested on how the different species would actually move as it dried, how much it would shrink, how much it would bend to kind of keep straight. Because in the end, I wanted to kind of use it to kind of panel the interior wall. So when you look out through the glass, you kind of see a representation of the mixture that's part of the forest on the inside. And, soft wood gets a bad rap. But what I found in doing this is that, the birch, which was going to be really beautiful, and I was really happy about the birch being part of the material palette. It's a hardwood, and it's really heavy actually. And I was like, oh, this is going to be terrific. In the end, even though that it's a hardwood and really heavy, it worked a lot more than the pine did. And it was a lot harder to control, and it was more brittle. It would break a little bit easier. The pine stayed so straight through the drying. We dried it for about 10 months naturally. And so one of the things that it helped me with is with a project that I'm working with on right now in Boston. I'm building a mass timber tower. It'll be the first mass timber tower in a major city like Boston or Chicago or New York that's burned down, that has pretty extreme fire departments there. But what was interesting about it was that, this site itself, I'm just going to fly through this, was an existing parking lot. And one of the things that we really wanted to do was actually keep that parking lot as open space instead of building the building on there. And we sort of squeezed into the corner of the site that wasn't originally really given to us, but we saw as an opportunity to kind of reduce the overall footprint and add an acre of open space back to BU's campus. They don't really have a central green, and we're trying to kind of create a central green with them. But what this did is push all the program high and skinny. We have a very small floor plate here. It's only like 6,000 square feet. But what's interesting is that at the height of about 12 stories or 180 feet, it's now you can go that high with timber structures. So it's actually as of right. And in 2024, you'll be able to go a little bit higher. And what's interesting about that, though, is that there are some caveats to the addendums to the code that allow you to do this. And one of them is that only 19% of the program, only 20% of the wood can be exposed. I actually have to cover up with chip wallboard the other 80% of the timber structure, even though the timber structure is fireproof and it's self-healing and will burn for 4 inches deep and stay way past what steel would stay past with its kind of fire coating on it. So what we did was we took 19% of the program was actually social spaces and collaborative spaces, and we sort of stripped the chip wall board from the structure, the all timber structure in those areas, and kind of revealing it and going through the kind of this strenuous process of trying to figure out how to do that, because now it's a code calculation that we're actually going to have to do, or we're doing right now to make that happen. But the interesting thing was we were kind of going through and thinking about different woods that we would be able to kind of source locally and even in America to do this. So we're working with 3 or 4 different suppliers who are bidding on it. We're going to go into ground next year on this, or earlier than that. And so we're going through the bid process now. And what I became more comfortable with is that in Arkansas we have more softwoods that are local, and in the lower regions of Canada, which is really close up, we have more softwoods. So I became a little bit more comfortable with using fir for the mass timber structures, because I had this kind of experience of like, wow, it is actually truer, straighter. We talk about it as being bad for floors, but being great for structures. This is something that I think people are starting to become more aware of. I mean, in the end, we didn't have a basement, so we did a steel building version of this with the mass timber, both having low carbon concrete, just taking a look at the structure itself. And by doing this, going structure, I don't think there's another mass timber tower in the United States. We're already down to the ground. We're not doing, 10 stories of concrete and then putting wood on top of that. we're reducing about 87% of the carbon that's associated with building a similar steel building in the same structure itself. And I think this idea of reason why it was a box and reason why it was very kind of simple, the monolith, is that we wanted also to reduce the amount of waste and reduce the amount of material needed to enclose a space. And so I think the last thing is really waste. Waste is kind of a big thing that we need to sort of take a look at.
Oh my God.
And this is real. This is my house.
Sewage, raw sewage in my own shoes.
That's my wife.
Medically, raw sewage.
Natalie.
What is that linked to? I don't know. Like, oh my God. Are you kidding me? Are you kidding me?
Are you making waves?
I'm trying, Sean.
So this was not Sandy. This was not a hurricane coming through New York City. This was a tropical depression that caught us by surprise. And what happened was we didn't flood from the storm surge. Where we flooded was from the sewer system. The rain became so intense so quick that the water blew through my backflow preventers and came through my toilet. And this is my daughter's room. So the irony of this whole thing is that my brother works with wastewater treatment systems. In Battery Park City, basically, they recycle all their water, their black water, and they use it for the last 20 years. This is nothing new. Last 20 years, for all their water that's required in the towers, they put two towers together, and they actually kind of recirculate that water. And so they use it for everything but potable water. But potable water is only 3% of the water that's being used in all these systems within the buildings we're creating, specifically the urban buildings that we're creating. So we took this idea and at DSR and with my brother, and we went to Venice. And in Venice, we said, Liz had this kind of crazy idea. She said, what if we could make espresso out of the canal? Because it's about perception. The canal's dirty. We can't use it. We have to pipe in water like the Romans did from very, very far away in order to use it locally. But the trick here was if we were going to create espresso, it had to have minerals. It had to have things of the water. It couldn't just be reverse osmosis like we're doing in other parts of the world, because that water could be from everywhere. It doesn't have any of the minerals that would make a really good, really place-specific espresso. And so we kind of worked through the kind of mechanical systems of actually doing two streams. One stream that's natural, going through a biofiltration process. One stream that's going through membranes, as you saw there, that Zach was showing you, that reduce the amount of salt in the water. Because one of the things that the natural systems can't do is reduce the amount of salt, because salt is dissolved really kind of low, but it can reduce everything else, or it can actually work and kind of filter everything else. And then we take those two streams and we put it together into a blend tank. And then in that blend tank, we bring to the espresso machine, the perfect blend, and then make espresso from it. And what's interesting about it was that we wanted to make it didactic, because it is about perception. We wanted people to be able to see this thing working really in its raw form, to get an understanding that we can actually keep water local. It can influence how we build parks. Within cities, it can influence how we actually, use the water that we thought was waste as something, as a resource, because only humans really think of, it's a human word, waste. Like everything else is decomposing in the forest. That would be considered waste, but it's actually nutrients that can be reused. We also did a lot of kind of tinkering with being able to reuse the steel, not welding the steel, but actually clamping the steel together so that it could be reused for different restoration elements around Venice, or be moved to other locations around the world itself. This is me and my brother watching the canal water go in for the first time. He's a little stressed.
For the first time. We'll
Trying to
see.
make this work.
The good thing is that the water looks dirty.
In the end, this just happened last week. We kind of opened it, and there was a lot of questions in the crowd, like, wow, you can actually, is this real? Can you drink the local water? And the truth is, it's not new technology. We can drink water that's closer to us. the same time, we're kind of messing with this kind of beta software to monitor it in real time. One of the things that's, was the most difficult is that this is the first time this was done, is actually getting it through the authorities, having the authorities actually, the health and authorities within the city, the safety authorities within the city. And so what we could demonstrate to them is that we can actually monitor this in real time, and know exactly the kind of turbidity of the water. So we know that it's safe and they can monitor it themselves remotely if they needed to monitor it. In the end, I think, we heard that it won the Golden Lion in the introduction.
The future of Venice is very interlinked with the future of water. And so in this case, it was an incredible team putting together design, architecture, putting together engineering, putting together in construction, one of the world's leaders in looking at construction and water. And in order to do something which is about how can we purify in a natural way water from the lagoon.
So pretty close by in Milan, Milan has the opposite problem. Milan doesn't have enough water. And so they're starting to take their wastewater treatment plants and trying to figure out a way to transform them so that they could use it for some of their reuse the wastewater for some of the industrial uses around the city, so the residents have clean, potable water. And so the question for us was, could we take, the existing fabric, the existing urban fabric, and find a way to actually reuse water, and create a place where people can kind of see it, experience it, but also kind of pull the kind of what we call an ensemble of buildings off of this central system, and recirculate its own water. In order to do this, we needed to do one thing that was really important. These commercial activities that we do in cities, they're only during a day. You need the loads of water and waste streams and power and heat happening at the night as well. So the ensemble was adding a new residential tower with the office tower and using the bridge, adaptively using the bridge to be this connection between the two of them, where the wastewater and the waste heat came down to the bridge, and the bridge itself, very much like the root systems of trees, would then take the nutrients out and then put the water back up into the towers for people to use again. We called it the living bridge. And basically what it did was it, collected, treated, reused the storm and gray black water system. So this is just blowing up the little experiment that we showed in Venice into a way to really adaptively change the urban fabric in a way that influences large scale development itself. So it starts with a screening tank going into the aquatic cells and the membranes, and then becoming 30,000 gallons of clean water a day for the towers to reuse, trying to target an overall net zero water demand. But what's great about this is that the greenhouse itself becomes a public space, but it's actually the mechanical room, if you really think about it. The aquatic cells become a place that people can explore, touch, feel, escape to in a semi-conditioned space between two buildings, very much like Z Park was itself. And the membranes itself, would be able to be within here after the water was treated naturally to finally, filter it to potable quality and become perhaps the platforms that people are walking on for the Fashion Institute or whatever exhibitions happening within this public space adjacent to the greenhouse area or the living bridge area. And we know that we can actually start to just, show this. We're doing it on our phones all the time now in real time to people, so they kind of understand that we need to rethink the way we use waste. We need to rethink that we had to build parks and then take care of them. This park would be taking care of itself. Our waste would be taking care of the park. We wouldn't be importing water from distances, importing nutrients from distances to maintain the park itself. And I think that's kind of things that I'm behind the scenes, and we are behind the scenes at DSR tinkering with. But I really feel that it's two things. It's about perception. And I think it's also about really doing the experimentation yourself, and testing yourself. Otherwise, I think it's really hard for tech to shape your work. if you're just sort of learning about it, but not playing with it physically. And so that's the only thing I would say to everybody is that if you have the opportunity, the experiments could be so small, but just those small experiments on your own time makes a huge difference in understanding what you can do later on.
Hi, Sean. Thank you so much for this presentation. It was very inspiring, and it was a bit surprising for me to see certain things that you shared. So thank you for that. It's
it wasn't
really
polished.
nice to see. No, it's
it
not
was
in
raw
that
behind the
sense.
scenes.
It was in the sense that it was very honest. You know what I mean? Like it was not like thinking from a commercial perspective or like it was very honest and almost like a conversation more than a formal presentation. Thank you so much. It was very inspiring. Well, I will start congratulating you for the award, of course, on Venice, the Golden Lion. And to start this conversation, maybe we can start with that project because the Canal Café, it's a remarkable project. It was for me surprising to read about it, a bit out of the box, which is always refreshing. And it's part an espresso bar, part a laboratory.
Yeah.
And it not only addresses water purification, but also reimagines Venice as a living laboratory for future urban life, and that it's very interesting, this combination. So could you share how this project reflects the studio's evolving relationship with sustainability and technology and public space?
Yeah. I mean, I think, zooming way out, we don't really talk about sustainability as the primary interesting thing. I think the interesting thing is how people connect with what you're doing that brings them closer to their environment. It's about that tangible moment. It's about that unexpected moment that I think really changes the way people think and eventually will start to change the way our culture acts and gets more comfortable with things that, 100 years ago were dangerous, but they're no longer dangerous any longer. Emergent technology is very different than the turn of the century technology in the 1800s, right? And so we've separated these areas between what can be industrial, what can be residential within our urban planning on purpose, because it was dangerous. We had to move it from the city, right? When we had cracking barrels for breaking down crude inside the cities and they exploded, that was a problem. And I think now, people only understand that history. And they don't understand when we're talking about, bringing these kind of resources that are inside the cities, these new industries that are inside the cities, they're different and they actually can make us healthier if we just keep these resources more locally. But in order to do that, you need to connect culturally somehow, right? So with the, cafe, right, having an espresso in Italy it's very Italian. Right. So, right. And so people are going to be like, oh, if we talked about it academically, and just said we can do this, and it was kind of a tech show thing, then people were like, oh, that's cool. But actually tasting the coffee, it brings them closer. It makes them interested in like, maybe I'll learn a little bit about this technology, but I don't know. But without that, it wouldn't really kind of bring it closer. And as far as the history of the practice, what, Liz and Rick and Charles, they come from, they're trained as architects, but they come from art and understanding culture, and specifically with our public spaces, trying to make things more visible to the public within the urban fabric instead of walled off. All those things are like revealing things to people to make them more social, more public. And I think, going back to, like I said, 2002 was when Blair was, thinking about using, inhaling water, right, as a way of new experience, right? So I think these curiosities continue, but I think, like you saw, you know, it's playing at a smaller scale. Like Rick was, Rick was into cars and making cars and stuff like that. He was tinkering with like, how does this actually work with the spray nozzle and the pressure of the nozzle? And if you don't really have that kind of tangible interest, it's sort of hard to push the technology in a new direction itself. You sort of have to play with it. But yeah, I think it's a part of a long, and there's other instances, throughout other projects we could talk about. I know we only had, 30 minutes, 25, 30 minutes. So I just kind of picked these three.
Thank you. And well, when you talk about technology and sustainability, these are two topics that often are discussed together, but they can sometimes feel at odds in practical terms. And my next question would be, how do you navigate this balance in your work? And what does it mean to embed sustainability strategically into architectural projects?
I think the conflict is interesting. Personally, and I know even, it's just that tension is where the magic is. I mean, the kind of vice virtue glassware, right? It's this idea of water's healthy for you, but you want a little bit more in it, right? To relax yourself, right? And it's like this conflict between two things that usually produces new grounds, new territory to explore. And so I think, the idea that technology can solve everything it's not true, right? It's that conflict from the idea that when you talk about sustainable practices, a lot of it's about being passive, right? And those are two different things. But I think if we can pull together the passive with, I'm actually really excited about this next century because it's the biotech century. So you're taking the natural and the tech, and you kind of putting them together. And I think if we can get a metabolism flowing within our cities, sort of like life has a metabolism, instead of just extracting things from afar, consuming them and dumping them, but we have this city that's kind of recirculating its own resources, and like our body kind of circulates our own blood and oxygen and reuses it, brings in small bits that's needed to replenish it, but also exhales and helps out the trees. Like if we can kind of get that going in cities, that mentality change, I think I just think that's the exciting itch that I want to continue to explore the next, however long I have.
Okay, that brings me to another question. That is, we've been seeing a broader shift in the industry of architecture, from using technology as a support mechanism to placing it at the core of the design process, right?
Yeah.
And how has this shift, or how do you see that this shift is influencing the way architects work?
Generally, it's good. Broadly, it's good. I think, in the 1960s, there was that underlying, interest among designers to be more passive, think about the environment in designing everything. And I think in order just to design, you should be thinking about all this stuff anyways, like the environment that you're placing this object in, or placing this place or housing structure or something in, is affected by the environment. The environment is and it's affecting the environment. So, like designing anything that's kind of, seamless and works with other stuff, we should be seamless and working with the place that it's in. So I think under everything, it should just be there. I think what's more interesting is that we find the cultural connections that might be influenced by the habits that make us a little bit more sustainable. And we got to bring those cultural activities to the forefront. And so for me, doing it just to say I can make the most efficient building, we're going to become more efficient over time. It's just the way that the human, we once we start doing something, we kind of really run it to the ground, almost in a bad way sometimes. But we're going to become more efficient. How can you make that more efficiency? Help our culture, help somebody locally, I think is the real question for me. Influence the way people think. Because if it's all behind the scenes and you don't see it, like as my brother's, Battery Park City, and those are my students from Columbia going down in there. No one knows it exists. It's in the basement. It's hidden. I think we need to take these things and make them more visible. And I think so the idea of sustainability being the forefront or saying at the focus in the center is great, but now we need to actually make sure that it doesn't overshadow the way that we can open up and make things more public. Because it's not all about just making things efficient, because the human body is not even that efficient. We can get like 80% efficient and people enjoy it. That's how things are going to move forward. If no one sees it, they're not going to push for it any longer.
Yeah, that's true. It's an interesting perspective. I have another quick question, and then we could jump into the questions from the audience.
Okay.
Is there any emerging technology that you believe will most significantly influence architectural practice or sustainability in the next decade?
I'm not sure there's one. I think it's more the category of experimentation. I'm truly interested in the biotech combination of the century, like thinking about natural systems as partners with the human systems that we've created. And we need people experimenting to find those new relationships, right? Biotech right now is seen as, we can actually 3D print metals to be able to place into people's elbows, make people live longer, right? It's like this combination of the natural and the machine. But I think that's mostly happening on the kind of medical side. And I think it needs to be happening more on the urban fabric, the place, the community side. And I think once that starts happening, that's what I see is going to really change the way, the way that our cities operate and tackle the kind of bigger challenge of not overheating ourselves like that we're doing right now.
Thank you. Okay, we have a couple of questions from our audience. The first one I would read is from Joey. Love seeing your tinkering approach to design. There's so much freedom and fun in that process. Your drawings also demonstrate a similar mentality. How does sketching and drawing by hand fit into your design workflow?
It doesn't fit. It is I can't, and people within the studio get a little bit frustrated with me, especially when we jump onto Microsoft Teams and I jump on. I'm like, I'm not using this platform, and set it up as a Zoom. Send me the link. If I can't draw, I can't collaborate. Like I have to physically be drawing. Like I'm always like, even when I move the press, I have to physically be drawing in order for me to understand things. I'm not a words guy. And so often my words, and even you can tell from that presentation, are confusing. But if I could draw, it's a lot more clear. So one of the things that I thought was amazing, and I wouldn't be doing what I'm doing today, was that I was never really good. I could draw going back in history, but I was never really, that wasn't my powerhouse of like being able to sketch and draw quickly in front of people. I was more of a model maker, a writer, in thinking about things, and I could draw, but it would take me time. And when the iPad came out, and I used to use those old chunky wood stylus for the iPads because, he refused to make a pencil for the iPad for the longest time. When the iPad came out, I started then to be able to draw and then go back to that drawing and actually actually send it to people really quickly. And so I started with just marking up my construction drawings for Rubenstein Tower. And it was kind of easy to mark up that way. I could be sitting on a plane. I'm not writing notes. I don't need my paper out there. I'm on a plane back to New York, and I'm just going wild with it. And the more that I started to like not mark things up, for certain moments of the day, I started drawing a lot more. And I think that enabled me, that new technological leap that you can draw on glass at any scale, really improved my drawing in a huge way that probably would have never happened if it was still relying on being at my desk, rolling out a piece of trace and marking it up for somebody and then send it back to them. I would be doing what most people are doing. They're in what's it called, blue beam, and everything's now typed with arrow pointers, right? And it's not that people drawing over top of the drawing saying, no, it should be like this. They're telling you what it should be like, but they're not showing you. And I think that's that ability to draw a lot more has made me better at thinking, but also better at being able to communicate. And I would encourage everybody, at first you start to draw on glass and it's like, whoa, you want that kind of tactileness. In the end, I think though, after you kind of muscle through it for a while, you can move so much quicker, so much more precise and slicker, that it actually I thought it made my drawing capabilities better. But it's every part of my day.
And last question, and then we wrap up because we are a bit over time. So, do you think the concept of technology is still sufficient to describe the tools and evolution we are experiencing today?
Yeah.
Yeah, okay.
I think, I think they're trying to get at the bigger question of what is technology. I like I said, technology doesn't always mean a new thing. Like people often like, oh, that's technology. It's like future. There's a lot of repurposing of older means and methods and tools that are very useful today if they're just tweaked a little bit, that we shouldn't forget about. I teach a course at GSAP called Emerging Optimism, but it used to be called, just it was about the industrial landscape. And one of the things that people don't understand is that the efficiency of the oil industry of refining crude is 99.6. They don't waste a drop. Everything gets turned into something. And so there's lessons to be learned from those industrial industries that the emergent technologies can start to learn from, because they're not efficient yet, right? They're in their premature state, right? But by ignoring how that was achieved, how basically the oil industry stole from the whiskey industry how to refine crude. I mean, it was a moonshiner in Pennsylvania that invented, basically kerosene by boiling down crude in his pot still and said, guess what? This kerosene, total accident, burns at the same rate as well blubber. Very safe, very steady, same amount of light. And at the time, the whaling industry, this is like 1878, 80, the whale industry was, dangerous. We whaled out the oceans and people were being lost. It was the whale industry had like scarred most of North America's coast, because they were just, pulling in kind of, slaughtering these whales to get at their blubber. And so this was, renewable. At that time, they thought, they were like, it's like a water well, renewable resource that is not as dangerous and not as harmful to the environment. Well, 100 years later, we know that's wrong, but it was the same pursuit at that time to make things healthier and keep people safer.
That's a good perspective. Thank you. Sean, we have to wrap up. Thank you once again for being here and sharing your work, your vision, and clearly your reflections on the evolving role of technology in architectural are not only insightful, but also very important in where the profession is heading. So thank you so much for sharing today.
No, thank you guys. Thank you.
Thank you, Sean, so much for this amazing presentation, and also to Daniela for leading such a thoughtful conversation.